All right, let's put you in the driver's seat. Imagine you're a cybersecurity consultant and you've just been called in to fix a system that's been designed to fail. That's exactly what we're going to do today. We're going to walk through the entire playbook, from uncovering the hidden flaws to pitching the final rock-solid fixes to the client.
So you just got the call. Your new client, we'll call them the Unsecure PWA Company, has built a progressive web app. Now, it's still in the testing phase, but here's the real kicker. It was built with vulnerabilities on purpose. Your job is to be the expert, to go in, hunt down every single one, and tell them exactly how to fix it. And here's the mission brief, plain and simple. You need to find the critical security holes, come up with solid fixes for at least 3 of the worst ones, document everything you do, and then you've got to present it all to the client. See, this isn't just about your coding chops. It's about how well you can analyze a problem, document your findings, and communicate the solution. So, here's our game plan. First, we'll lock down the mission objectives. Then, we'll get to know the enemy, the common vulnerabilities you'll be looking for. After that, we'll map out our investigation, figure out how to structure the security report, actually build the fixes, and finally, prep for that all-important client pitch. Okay, first things first, the mission. You can't hit a target you can't see, so it all begins with understanding exactly what the client needs and what's in and out of scope.
So here are the key details. The client is the Unsecure PWA Company. The project is their progressive web app, and yeah, it's currently a bit of a mess by design. Our main goal, find and fix those weaknesses. And we'll know we've succeeded when we hand over 3 things: a detailed security report, the actual secure code, and a killer client presentation.
Look, you can't fight an enemy you don't understand. So before we even think about writing secure code, we need to know what we're up against. Think of this as our field guide to the usual suspects. First on our list is a real classic, SQL injection. Imagine this. Instead of using a key, a burglar just yells a special command through the mail slot that tricks the guard inside into unlocking everything. That's kind of what this is. By sneaking malicious SQL code into a simple login box or search bar, an attacker can trick the database into giving up all its secrets. And yeah, that analogy really hits the nail on the head. An SQL injection doesn't brute force its way in. It cleverly convinces the system to open the door itself. It's a masterful way of turning the application's own logic against it. Next up is cross-site scripting, or XSS. Now this one is really sneaky. The attacker doesn't go after the website directly. Instead, they plant a malicious piece of code on the site, maybe in a forum post or a product review. Then when you or I visit that page, the script runs in our browser and can steal things like our login cookies. The website itself becomes the weapon. And the list doesn't stop there. We've also got to be on the lookout for cross-site request forgery, or CSRF, which tricks a user who's already logged in into doing things they never intended. Then there's broken authentication. Think weak passwords or sessions that never expire. These are just open invitations for attackers. And of course, API security is absolutely critical for any modern app. Okay, we know what we're looking for. Now we need a plan. A real security assessment isn't just poking around hoping to find something. It's a systematic, planned investigation with the right strategy and the right gear. A really solid investigation is built on 4 pillars. First, you define the requirements. What does this app actually need to do? Then, you lay out the security specifications. What tools are non-negotiable, like using bcrypt for passwords? Third, you do an impact assessment. What's the actual damage in dollars and reputation if this thing gets hacked? And finally, you do penetration testing. You actively try to break in to prove it's secure. Now, that last one, penetration testing, it's not always an easy sell. It takes time, it costs money. This is where you, as the consultant, have to make the business case crystal clear. You have to convince the client that whatever it costs for you to find these flaws is nothing, and I mean nothing, compared to the cost of a real attacker finding them first. Finding and fixing things is only half the job. I mean, if you can't clearly communicate what you did and why it matters, its value just gets lost. That's why a professional security report is absolutely essential. Your report has to be logical. You start with an intro that sets the scene. The findings section is really the heart of it. That's where you break down every vulnerability you found, the potential damage, and the proof. Finally, the fixes section is where you lay out your solutions, complete with code and a clear explanation for why you chose that specific fix. And listen, I can't say this enough. Evidence is everything. Your claims mean nothing without proof. So as you're testing, you have to be meticulous. Grab screenshots, save error logs, copy terminal outputs. This is the stuff that makes your report undeniable and your recommendations impossible to ignore. All right, now for the fun part, turning all our detective work into actual, robust defenses. It's time to build the fixes. This is basically our go-to toolkit. For broken authentication, two-factor authentication is a must-have. For passwords, you never, ever store them as plain text. You use a strong hashing algorithm like bcrypt. And for any data a user gives you, it's a 1-2 punch. First, validation to check if it's in the right format, and second, sanitization to neutralize any hidden dangers. Now, it is so important to know the difference here. Think of it this way. Validation is like a bouncer at a club checking your ID. Does your data follow the rules? Is it a number when it should be? Is it under 8 characters? Sanitization is the security pat-down that comes next. It assumes there might be something dangerous hidden in the data and cleans it up, like removing nasty HTML tags to stop those XSS attacks. You absolutely need both. So you've done the work, you've written the report, now comes the moment of truth. You have to convince the client. And there's this really powerful technique for building your argument called the 5 whys. Here's how it works. You just keep asking why, like a curious kid. So, why is data confidentiality important? To protect sensitive info. Okay. Why do we need to protect it? To prevent data breaches. And why do we care about breaches? Because they cause massive financial and reputational damage. Why does reputation matter? Because it's how you build customer trust. And finally, why is trust so crucial? Because without it, you don't have a sustainable business. See? You just built an unbreakable chain from a technical detail all the way to the company's bottom line. And this isn't just some neat little communication trick. This kind of deep justification is what separates a pretty good consultant from a truly great one. It proves you don't just know what to do, you understand why it's vital to the business. It takes your work from just a technical report to actual strategic advice. And if the client ever needs one last visual to drive the point home, this is it. The investment in proactive security, in people like you, in proper testing, it's tiny. It is a fraction of the catastrophic cost of a data breach, a cost that you measure in lost customers and a ruined reputation. So, you've handed over the report, you've delivered the secure code. The PWA is 1,000 times safer than it was. But is the job ever really done? Cybersecurity isn't a one-and-done project. It's a constant process. Which leaves us with the ultimate question you have to ask about any system, no matter how well you've built the walls. Is it ever truly secure?